All right, good morning, everybody. It's 9 o'clock. Happy Monday. I hope you guys had a good weekend. Really exciting. I'm having lots of people come into my office hours now, so I really appreciate you guys coming in and getting that done. So just remember, if you guys need help with your homework or you need help with anything, just to join me in my office hours and we can work through everything, okay? Remember, as we go through today, if you guys have questions, to use chat to ask questions or to turn on your mic and ask questions that way. Okay, so let's go ahead and take a look at this warm-up that I posted, and let's get into the lesson today. So this is day 2 of exponential decay, right? So we spent 3 days on growth, and now this is day 2 of decay. We're going to spend 3 days on decay. And that's really it, guys, for this trimester. So we're going to finish out decay, and then we're going to review everything that we covered this trimester, and then we're going to take our final. Okay, so we're in the home stretch. So if you guys have missing assignments, make sure you guys get those done now, because there's not a lot of time left. Okay, so taking a look here at what we have. So our first equation here, we got 37 times the quantity of 0.86. So the first question I would just ask of you guys, just looking at this right here, is this going to be a growth or a decay? And how do we know? So again, taking a look at this, is this going to be growth or decay? And you guys can respond in chat, or you can use your mic. So the question is, right here, looking at this equation, is it growth or decay? And so I see some people, they're not quite sure. So remember, we want to be able to know if this is growth or decay. And the way that remember is that growth is greater than 1, and decay is less than 1. Okay, so is this less than 1 or greater than 1? Right, this is less than 1. So this is going to be decay. And that's how you know if it's going to be decay or growth. If it's greater than 1, then you have growth. If it's less than 1, you have decay. So since 0.86 is less than 1, we're going to be getting smaller. Okay. So what is the initial amount? So the initial amount is going to be our A term right here. So it's always in front. So there we got 37. Right? And you guys have been seeing this a lot on your homework, right? Where it gives you an equation and it says what's A. So A here is 37. That's our initial amount. Okay, and so our initial amount is 37, and we're going to be decaying. Now, remember, for decay, it takes one step more. So this is 1 minus R. Okay, so it's 1 minus our rate because it's less than 1. So I have to remember, okay, 1 minus R equals 0.86. So if I add R to both sides and I subtract 0.86, so I get 1 minus 0.86 equals R. And I can use my calculator for that. And maybe I'm going too fast. Sorry, I did some algebra there. Okay, so what I'm doing is I'm finding R. Now with decay is a little bit more difficult to find the R, because you can't just go, oh, it's 1 plus R, right? So we have the 1 minus R. We have to do a little bit of algebra here. So what are we going to have? We're going to have 1 minus 0.86. And I get my R is 0.14. Now, that's all good as a decimal, but I want as a percentage. So to do a percentage, I'm going to multiply that by 100. So I take 0.14 times 100, and I get that my rate is 14%. Okay. Now, again, this is the difficult part, right? This is what makes decay more difficult, is that you can't just look at it and be like, oh, the decay is 86%. And one way to think about this, guys, is that if you go to a store and it says 14% off, right, you're paying 86% of the total, okay? So it's 14% off. So think of that word off. Off means subtraction. So it's off of normal. Okay, and that's what this says right there. So when you say 14% off, it's really saying 14% off of 100%. So it's 100% minus that. That's the 14% off. Okay. So it's 14% off. All right, and I know we're going to have to practice doing this because it's different than doing the growth. So we look at this one. So this one's a bit different, right? So notice how it doesn't have the parentheses that are normally there. So it says, what's the initial amount? So this got a lot of people probably in your last homework. So if we look at this, what number is out in front? So a lot of people will say either 1 or 0. But think about this. If we have 0 for an initial amount, can you grow anything or decay anything from 0? Right? If you have nothing, you're not all of a sudden going to get more. And if you have nothing, all of a sudden you're not going to have less. Nothing is nothing. So the initial amount is never going to be 0, because if it was 0, then it would always be 0. So in this case, we're just lazy and we don't write the 1, right? So there's a 1 right here. And we're just too lazy to write it. So this initial amount is 1. So I just wanted to make sure we took a second to take a look at an example of that, because I imagine that might have confused some people in their homework, their last homework. Okay. So the initial amount here is 1. And then what's the percent rate of change? So again, this is less than 1, so this is going to be decay. And we have to, oops, it's a Y, not an R. So we're going to look at decay. So this is 1 minus R. So I have 1 minus 0.74 equals R. So I'm going to take, oops, that's not true. Yeah, I should start from the beginning. 1 minus R. I mean, it is true, but I should start from the beginning so that I don't confuse people. Right? And then I'm going to add R to both sides, subtract 0.74 from both sides. So I get 1 minus 0.74 equals R. Okay? And I'm going to type that into my calculator. So I'm going to get 1 minus 0.74, and I get that my R is 0.26. Okay? And then if I multiply that by 100, I get 26%. Okay? That's my rate of decay. And this was decay as well. Okay, so I know that some people are going to be struggling with this. That's why we're spending today and next class, so today and Thursday on that. And this is going to be the last thing that we're doing this trimester before next trimester. So does anybody have questions or comments before we just jump into practice? So this is a review of what we did last class, and what we're going to do today is we're going to take a look at word problems, and we're going to practice doing these. So does anybody have questions just based off what we did in the warm-up? Did I go too fast? Did I not explain something? Were you confused by something I said? Any questions? Okay. All right, so I only got a very little feedback. So just remember, guys, if you need help or you're stuck or something doesn't make sense, please let me know. I want to help you. I want to make sure you feel good about this stuff. Okay. So what we're doing today is we're going to take a look at so of course my PowerPoint that I was getting this problem off didn't load. There we go. We're going to take a look at some decay word problems, and then we're going to answer some questions. Okay, so let's go ahead and take a look at this. So let's say, so one example of decay is if you work at a hospital, especially in an ER room, one of the first questions is that they'll ask you, that a nurse will ask you when you get admitted to the hospital, will be, are you taking any prescription drugs or have you taken any painkillers? And the reason for that is that those chemicals stay in your body and they slowly decay over time. And they need to know, well, how much of those chemicals are in your body so that they don't give you more of that chemical and then bad things happen, right? So let's say there is man, I'm trying to think of, I don't want to use scientific words because we don't all know the scientific words. Okay, so let's say a person in ER, and ER stands for emergency room. So a person in the hospital, so a person in ER has what's an amount? Let's say grams. Let's say has 2 grams of painkiller in their body. Okay, so a person comes into the ER and they're like, hey, I took this much Advil, or I took this much Tylenol. Okay, let's say like you were building something in your house and you got injured and you're like, I took some painkiller but I had to go into the ER. So you tell the nurse that you have 2 grams of painkiller in your body. Okay, now as a nurse, I know on average that the amount of painkiller goes away at 5% per hour. Okay, and if you guys have ever taken a painkiller before, like Advil or Tylenol, right, you know it doesn't last forever, right? So eventually the effects wear off, right? So we're saying is that you show up to the hospital, you have 2 grams of this painkiller in your body, and the amount of painkiller goes away at 5% per hour. So the hospital says, okay, we can't give you more painkiller until a certain amount, like until your blood level reaches a certain amount, because they don't want you to overdose on a painkiller. Okay, so that's why it's always important when you go to the hospital that if you've taken any pills that you need to tell the people so there's not side effects. Okay, so what we're going to do is we're going to break down this problem together. So the first thing we're going to do is we're going to write an equation. Okay, so when we go to write the equation, so the first thing we need to figure out, is this going to be growth or decay? Well, we're working on decay, right? So the thing that I would say, it's going away, right? So if it's going away, this is decay. Okay, so in your notes, you guys remember we took notes on this. There's two formulas, right? One for decay and one for growth. For decay, we have y equals, and then we have a, and then we have 1 minus r to the t. Okay, so if we're going to write an equation, we need to figure out our a, and we need to figure out our r. So let's do that. And this is what we've been really working on in our homeworks, right? So in chat, what's our a? Right. Our a, right, is our initial amount, so it's going to be 2. So we got 2 grams. And then our rate, so it's decreasing at 5%, right? So my rate is 5%, but I want to write that as a decimal. So that's going to be, if you divide this by 100, we're going to get 0.05. Okay? And if you forget how to do that, you can just take 5 divided by 100. Oops, sorry, that light's kind of bright. So I have 5 divided by 100 is 0.05, and that is 5%. Okay? If the 5 was in the first decimal place, that would be 50%. Okay. So we have our A, we have our R. So I'm going to go ahead and write my equation. My equation is going to be y equals 2 times 1 minus 0.05 to the t. Now, Big Ideas is going to want you to simplify this. So in our calculator, we're going to go 1 minus 0.05. And what I get is 0.95. So I'm going to write y equals 2 times 0.95 to the t. And this is going to be my answer. It's super important, guys, that you have this in your notes. You're not going to want to write this for your answer. You want to write this as your answer because you can do this in a calculator. So this is helpful for us to remember, but then we can use a calculator to be like, what's really happening here is that every hour I have 95% of what I had last hour, right? So every hour I have 95% of what I had last hour. That's what that means. Okay. So again, we're doing this problem together so that you're seeing it, you're exposed to it, you have notes on it because you guys are going to try one of these out in just a little bit, okay? All right. So let's practice now using this, right? So how much painkiller is present after 3 hours? Okay. So I want you guys to type this into your calculator, right? So it says how much painkiller is present after 3 hours. So we're going to take that t, replace it with a 3, and you guys are going to tell me what y equals. So take a second, grab a calculator, and we're going to plug in 3 for t. And you guys can do that on your own. Right, this is what we're typing into our calculator. You guys are either using a physical calculator or using Desmos Scientific Calculator. And then I hit enter. And so I didn't tell you guys where to round this, so we're just going to write this out. Oop, let's see if we can see it though. So I get y equals 1.71475. And then it's in grams. Okay. Now, if I was a nurse at the hospital, we would have guidelines and saying, I can't give this patient more painkiller until it reaches a certain amount in compared to their body mass. Now, we're not going to get that technical. This is just an introduction, but I'm just trying to show you guys how this would be used in a quick setting. So you'd want to say, okay, what did you take? How many grams was it, or milligrams? And so they can figure out how much is in your blood, okay? And then that way, so then if it's really close, they'll take a blood sample and they'll figure out how much is in your blood so they know what they can safely give you. Pretty cool stuff though, huh? Maybe. Okay. All right. So again, this is a lot like what we did with growth. What's different now though is we're doing decay, so it's going to be 1 minus. Okay, so what we're going to do today, so this is kind of our example problem. We're going to do a couple of problems, and you guys are going to try them out on your own. And I just want you guys to see how you're doing. Some of you are going to be like, I got it, first time. Others are going to struggle. So if you're struggling, that's totally okay. That's why we're spending time on it. I just need to know where you're struggling so that we can correct it. And then next time you don't struggle there, hopefully. All right? So anybody have questions before I move on to an example where you guys are going to try on your own? Thanks, guys, for the feedback. I appreciate the feedback. And just remember, guys, I want to hear if you guys are struggling so that I can help you out. Okay. So it looks like you guys are doing pretty well right now. All right. So let's do this next one. Let's see if. All right. Ooh, I'm gonna try something out. Just give me a second. I have an idea. And it just came to me. I'm gonna use the technology to make this easier for you to read. So if I save, I'm gonna call this. What am I gonna call this? All right, and I hit save. And then what I'm gonna do is I'm going to add a new layer, and I'm going to add an image, and I'm going to where did I save it? Oh no, where did I save it? Guys, I'm so sorry. Work with me here. I thought this would be fast, and then it wasn't fast. Then it wasn't fast. Sorry, just a second. I'm gonna try again. Okay, so it's on my desktop. Just a second. It's on my desktop. Images and videos. So it's on my desktop. It's called problem 1. Why isn't it showing up? Oh gosh. Oh gosh. Okay, let's try this again. File, save as, and we're gonna try putting it in pictures. Okay, let's try this now. There we go. Oh my gosh, it's way too zoomed in. Oh my gosh, this isn't working. All right. What if I go like this? All right. I'm just going to. We're gonna have to end this. It's not working. Remove layer. Sorry guys, I tried to make it cool and it wasn't cool. So now I'm gonna have to just do it by hand. I'm really sorry. We didn't have to round in that one. So if it says to round, then you need to round. Okay, so here we go. Here's your example. I'm so sorry. I thought I could make it work and it didn't. So let's say the value of a car is 30,000. Okay. The value decreases by 18.9% each year. Okay, so you're going to A, write an equation. For the value. And then B, what is the value of the car after 15 years? Okay, so let's go ahead and do that. I'm going to give you guys a little timer to work on this, and I'm going to figure out this whole image thing. So I'm going to give you guys 3 minutes on this. Okay, and let's go. Oops. Sorry about that. That's too bad. All right, guys. So let's go take a look at this. So in order to write an equation, so it says decreasing. So we know it's going to be decay. Okay. So if it's decay, then I know y equals a times 1 minus r to the t. So we have to figure out a. So our a is going to be, we started out at $30,000. And then the r is, so we want to write this as a decimal, so I'm going to divide this by 100, so I get 0.189. Okay. And that is 18.9%. So if you go ahead and write this as an equation, that's going to be 30,000 times 1 minus 0.189 to the t. So then when I go to do this, I'm going to go ahead and type this into my calculator. So I'm going to have 1 minus 0.189, and I get 0.811. So then I would have y equals 30,000 times 0.811 to the t. So this is the equation that I'm going to use. Okay, so that's what I got. Does anybody have any questions about that? Thank you, I appreciate that for the feedback. Thank you. Okay. So then it says, what's the value of the car after 15 years? So this is the percentage per year. So I'm just going to take my equation. So 30,000 and then 0.8111, and then I'm going to plug in 15. So I'm going to have 30,000 times 0.811 to the 15th power. Okay, so we make sure that we're typing it into our calculator correctly. And I get y equals, I'm going to go ahead and round to the second decimal here. I should have said that at the beginning. So I'm going to have 1,295.49. And that's in dollars. Okay? So you can see the value of the car really dropped off. And this is true. If you buy a brand new car, as soon as you drive off the lot, the value of your car has decreased a lot. Cars are not good investments. They reduce in value quite a bit. Okay, so that would be my answer. Okay, how did we do with that, guys? We doing okay? All right, well, I'm not getting any questions. So just getting people saying that they're doing okay. So I appreciate that. So let's do one more and see if you guys can get this and just kick it out of the park. And if you guys are like, hey, I'm doing really well with this, just remember your homework is just like this. So if you're lost, make sure you're asking questions because the homework is what counts. And if you're getting this, then this is really good. So we'll call this example 2. Okay, so so let's say here, I like this one. So let's say a scientist introduces an antibacterial. So an antibacterial is like penicillin. So if you have a bacteria infection, you would take penicillin to help get rid of it. So a scientist introduces an antibacterial agent into a culture. A culture is like you have a little dish with blood in it, right? So in science, you might have done that. They're like the circular dishes, and you swab something in it. That's a culture of, and then we're gonna say 1 million bacteria. And that doesn't, oops, there's an ER there. That doesn't sound like a lot. I mean, it sounds like a lot, but it isn't that much, right? Because bacteria is really small. So a scientist introduces an antibacterial, which is like penicillin, agent into a culture of 1 million bacteria. Okay. The bacteria starts to decrease by 30% each hour. We're doing a lot of medical stuff today, huh? A lot of medical stuff. There's lots of reasons for decay, but medical is a good one. Okay, so a scientist introduces an antibacterial agent into a culture of 1 million bacteria. The bacteria starts to decrease by 30% each hour. Okay, we're going to do the same thing here. We're going to write an equation. So write an equation for the amount of bacteria So we're going to write an equation for the amount of bacteria, and then B, how much bacteria is there after, what do we want to do? After 2 hours. So we're going to go ahead and give this a try. We have an antibacterial agent reducing the amount of bacteria by 30% each hour. And we're going to write an equation, and then we're going to figure out how much we have after 2 hours. Okay, and I'll give you guys 3 minutes for this as well. All right, hopefully that was enough time for you guys. Again, if you have questions, you can always ask questions while we're working on things. That's what this is all about, so you guys can ask for help and get help if you need it. So let's go ahead here. So I'm going to write my equation. So remember, it's decreasing. So I'm going to have y equals a times 1 minus r to the t. My a is going to be 1 million. So that's 6 zeros. And then my rate is going to be 0.3. Okay. So when I go to write my answer, I'm going to have y equals my initial amount, so 1 million, so that's a 1 with 6 zeros, and then 1 minus 0.3 to the t. But I'm not going to leave my answer like this. I'm going to type that into a calculator. So I'm going to get 1 minus 0.3. So I get 0.7. So my answer then is going to be y equals 1 million, right? So that's a 1 with 6 zeros, and then 0.7 to the t. Okay. Now, I wasn't getting any questions in chat. Are you guys doing okay with this? I'm assuming since I didn't get anybody asking questions that I could go a little bit more quickly through this. Am I correct? Are we doing okay there? So how I got the 0.7 is that 30% is 0.3 as a decimal. Okay. Now look at this equation. This is my equation for decay, right? So decrease means this. So it's 1 minus r. So if r is 0.3, then I'm going to go 1 minus r. So I get 1 minus 0.3. So on my calculator, I went 1 minus 0.3, and I got 0.7. Right, and this is the part that makes the decay difficult, right? We have that extra step. We can't just put in 0.3 here. So it's 1 minus 0.3, and that's how I got 0.7. And for the people who were asking me questions, is that helpful? Did that help? So again, you take your percentage, you make it as a, okay, thanks guys. You take your percentage, you make it as a decimal, and then we just have to make sure that we plug it into the equation, right? And remember, we don't have to do this step when it's growth, and that's why this is more difficult. There's an extra step. So we just need to make sure we do the 1 minus 0.3 to get that 0.7. Okay, I'm glad, and thank you guys for asking questions, right? I appreciate that, and because remember, I'm here to make sure you guys get it. So how much bacteria is in there after 2 hours? So I'm going to go y equals 1 million 0.7, and it says 2 hours. So I'm going to replace this t up here. I'm going to replace that with 2. So I'm going to take this and I'm going to plug this into my calculator. So I get, now sometimes this can be difficult typing into a calculator if it doesn't add add commas. So what I do is I do the number in front and then I just count how many zeros. So there's 6 zeros. So I go 1, 2, 3, 4, 5, 6. And then I go 0.7, and then I'm raising it to the second power. So I do that, and I get, oof, there's a lot of zeros there, isn't there? So I get y equals, let's see if I can get this back on here, 49, and then how many zeros are there? 1, 2, 3, 4. So 1, 2, 3, 4, and then I go like that. So it looks like there would be 490,000 bacteria. Now, so it's a little bit less than half. I mean, a little bit more than half, right? So, I mean, it's a little bit less than half of what we originally had. Okay. Well, it's a little bit more. Okay, that's a weird English thing. All right, cool. So, hey guys. I just want to make sure I have quite a few people who aren't doing their homework assignments. So remember, your homework assignments, I've made them only 4 problems long. So they're only 4 problems. And they need to be done, guys. People's grades are starting to take a drop because homework is not being done. So if you're having issues logging into your homework, if you're having issues doing your homework, please let me know. I want to help you. Make sure, I hope you guys have been in advisory, that you guys have been checking Skyward and checking your missing assignments. You guys have been doing that, right, in advisory? Because I know in my advisory class, we've been checking Skyward. Yeah. So if you're having issues doing your homework, you have to let me know. So, and I'll reach out to you. I'm going to send you an email in just a little bit, reaching out to you. But if you guys have issues, I have office hours at the start of every day. So, and you guys can just come into my office hours. You can be like, hey, Mr. Kraft, I'm working on what assignments are we working on now? I'm working on 6.4 day 2. And I'll pull it up and we'll be like, okay, what problem are you stuck on? And we'll work on the problems together. Okay. And that's something that I really want to help you guys out with. I want to make sure you guys are getting your homework done. So again, if you guys are having troubles, there's no problem with just sending me an email saying, Kraft, I'm struggling with this one. So I have office hours. Yeah, let's talk about this. So my office hours, if we look at the day of the week, so I have Monday, Tuesday, Wednesday, Thursday, Friday. So Monday, it is 6:35 to 8:50 a.m. So it's these 2 days, and then these 2 days, it's 6:35 to 8:50 a.m. Okay, so it's right before we have class, and it's also on Tuesdays and Fridays. Okay, so for example, you're gonna have a homework assignment, and it's gonna be due Thursday. So you can come see me tomorrow morning. You can come see me Thursday morning before class. So there's always going to be 2 office hours that you guys can come in to work on your homework before it's due. Okay. Also remember, I just really want to stress this, that there is no late penalty. So if you guys are like, oh man, I have all these missing assignments, but I'm just going to like it's just not worth it because they're all going to be late. No. This year, your grade is just based off how are you doing on the homework. So you just need to do it. There's no late penalty. And if you guys turn in an assignment and it's less than the grade that you want, you can always keep working on it. So so if you, as far as today, you can always work on your assignment today, right? You can always work on your assignment. You can send me, if there's a question, you can ask me an email form. I can help you an email form. The reason why I have my office hours in the morning is because I coach soccer. So I head down to Mount Vernon around 2. So that's why I don't have office hours in the evening anymore. So if you want, you can send me a quick email and just be like, hey, I'm stuck on this problem, and then maybe I can help you out there. Okay, guys, it's so important that you guys right, because just imagine if we get this work done and you get the grade that you want, you're done with Algebra 1, right? Next year you're going to move on to geometry, and you'll never have to take Algebra 1 again, and you'll be done with it, and you'll be like, wow, I made it through COVID, and we made it through Algebra 1. So that's the goal. I'm here to help you. Don't feel like you have to do this on your own, okay? All right, so with that said, guys, I really want you guys, we're out at 9:50, so there's 2 minutes left. If you guys want to go ahead and just log on to Skyward and check, hey, has Mr. Kraft graded all of my assignments correctly? Because it could be maybe you turned in an assignment late, and I didn't know that you turned it in late. So if you check Skyward and you're like, oh, it says this is missing, it shouldn't be missing, then you should send me an email and be like, hey, Kraft, I did this. Because Big Ideas doesn't tell me when you turn in an assignment late. Okay? I don't get an email. So make sure, I would get on right now to Skyward, be like, hey, what assignments am I missing? If you've already completed it, send me an email saying, hey, Kraft, I already turned this in. Can you please update Skyward? And I will. And if you see missing assignments, make a plan to get a few of those assignments done, right? Remember, there's no school Wednesday, so you can use part of that time to work on it. And you can always email me, guys, and ask questions. And I can be like, oh, you're stuck. Like, tell me what assignment and what problem so I can help you out and where you're stuck. Okay? So with that said, I'm going to